When submitting a prompt in Google Antigravity 2.0, the action doesn't travel in a straight line. Instead, it splinters, triggering dozens of simultaneous, independent tasks. You're now faced with a choice. You can stick with established, linear coding assistants like Cursor or Claude Code, or you can drop that mental model to learn a system built on orchestration. This diagram maps the core difference. On the left, the traditional sequence. A developer prompts an agent, writing directly to a single file, updating line by line. On the right, Antigravity 2.0. You delegate to a manager, spinning up concurrent background workers for parallel implementation. Adopting this platform means trading your direct keystroke-level control over code generation for the ability to execute parallel operations at scale. The first version of Antigravity was built as an editor-first IDE with an AI side panel. Version 2.0 shifts that architecture into a standalone desktop application that is decoupled from the text editor. Because of this decoupling, you lose the inline edit-by-edit diff view. You can no longer watch the agent actively change your code in real time. The platform defines work as a task assigned to an agent, shifting focus away from the files themselves. Stripping away that granular visibility forces a specific behavior. You have to treat the AI as a project team, delivering completed artifacts, rather than a smart typewriter capturing your thoughts. This tree structure shows how orchestration operates in practice. A main agent takes your objective and spawns parallel, role-specific subagents, like a researcher, an implementer, and a tester, to execute the work simultaneously. It can pull from a standard roster using the invoke subagent command, or it can write new custom configurations on the fly using define subagent. Because these agents run out of sight, you must provide strict, detailed planning up front. If your spec is vague, you'll wait for the final artifacts only to realize they built the wrong thing. To keep these parallel workers from overriding each other's code, the platform uses a system called Worktrees. This diagram illustrates the inherit mode, where multiple subagents share the exact same environment without any local Git overhead. It runs quickly, but if two agents try to write to the same file simultaneously, they will collide. To fix that, you use share mode. This isolates the subagents into separate branches, while keeping them connected to a single physical storage checkout. The cost of that isolation is cleanup. When an agent fails or a task is terminated, its logs and artifacts remain preserved on your desk, requiring you to manually review and clear them out. To achieve true parallel orchestration, the time you used to spend writing functions is reallocated to managing isolated environments and resolving Git branches. You also have to decide how much cognitive power each task actually needs. You are responsible for routing work to different AI models based on the complexity of the prompt. This decision matrix breaks down the routing logic. For routine implementation and browser operations, you send the work to Gemini 3.5 Flash, which delivers high throughput and speed. However, if you give Flash an ambiguous specification or a poorly defined architecture, its accuracy drops sharply. When the job involves architectural reasoning or requires recalling context across a massive codebase, you route it to Gemini 3.1 Pro. That extra reasoning capability comes with a noticeable latency tax. It will take longer to get your output. Your rule of thumb is simple. Default to Flash for speed, and only pay the latency tax of the Pro model when the task demands heavy thinking rather than repetitive doing. Early users are reporting significant stability hurdles with Antigravity 2.0, particularly regarding the browser verification agent. When the application updates, background processes lose sync with Chrome. This jams port 9222 with stale connections, throwing a persistent network.enable timed out error. To clear that block, you have to force kill every Chrome process on your machine, meaning you will lose all your open browser tabs. If that doesn't fix it, your antivirus software is likely flagging the Chromium driver in the background. You have to go into your settings and manually whitelist the application directory. A subtler risk occurs when the browser agent encounters an error and decides to skip the visual audit. It will report that the task is deployed based solely on the code it just wrote. You cannot trust that summary. If the browser tool fails, you have to open the preview yourself and manually verify the UI changes, or you risk shipping broken work. This pricing table outlines the current financial math. The public preview tier gets you free access to the Gemini models, but heavy daily use will hit the platform's throttling limits. To lift those restrictions, there is a new AI Ultra tier at $100 a month, which grants 5 times the usage limits of the base plan. That price point sits higher than alternatives like Cursor, which charges a $20 flat fee, or Claude Code's usage-based billing. Upgrading to that $100 tier only makes mathematical sense if your daily workflow relies on continuous, multi-agent background tasks running in parallel. This scenario matrix maps out exactly who should adopt this platform today and who should stay with their current stack. If you already dictate architecture and let AI handle the implementation, this tool matches your workflow. For solo founders, the scheduled tasks and parallel subagents let one person act as a project manager, steering multiple work streams at once. And if you're simply curious about the agent-first direction of the industry, the free public preview makes evaluating this system risk-free. However, if you are an engineer who needs to audit every line as it's written, losing the live diff view will be frustrating. Your workaround is to keep the legacy IDE, or Cursor, open on a second monitor, just so you can watch the file tree update while the agent works in the background. Finally, if you lead a team prioritizing stability, the launch week crashes and core dumps make this a liability for production deadlines compared to established tools like Cursor or Copilot. The landscape of AI tools has officially split. You have to decide if you want to optimize for typing code faster or orchestrating agents at scale. To help you make that transition, visit the free DDS5 Academy page at DDSBoston.com. You can download the exact system prompts, custom rules files, and the Chrome reset scripts we covered today. Grab those resources to stabilize your setup and check back next Friday when our next technical masterclass drops.